I'll try to get you folks to your break on time, particularly because this time of year, Halloween's coming up, and I like to watch horror movies. And most horror movies, there's usually some ghost or something in the background, and it's we start yelling at the screen like, "He's behind you!" We start seeing like this bright white legs in the shadows over here. Someone let me know he's behind you, and he's wearing a dark hoodie, so all you can see are his shiny shins, you know? All right, so I'm excited to be here today to talk to you folks about designing alerts to direct attention. I'll tell you a little bit about myself first. I'm a software engineer. I've been doing this for about 20 years, working in operations, writing code, building teams, and being woken up in the middle of the night. I also like to rescue dogs. The Dobie here is Lola. There's a Lab Beagle mix there, Umi, and clearly my favorite one, that's Sky. She's a Pit Husky mix. And I worked at a couple companies, Bloomberg, Etsy, things like that, but I've since left that job to show everyone pictures of my dogs. So as we get started, and especially as you leave here and you're thinking about the presentations that you've seen today, there are two things I want you to take away from this presentation as you're letting these things soak in. The first is that humans and computers are already working in concert to achieve a goal. Start thinking about computers as teammates. I also want you to be thinking about what directed attention means. And specifically in the context of this presentation, how it is we can have computers aid directed attention in meaningful and appropriate ways. So I think before we get started, it's useful to have a discussion of what systems are. And if you've read Donella Meadows' Thinking in Systems, she provides a really fantastic and simple definition or an illustration of systems in the abstract, starting with a stock here. And there are three components in any system. There's a stock, flows, and feedback loops. And she says that the stock is an accumulation of information that has built up over time. And she further goes on to describe that the stock is also the present memory of changing flows. And for us today, that stock right there represents our system state or systems state. Whatever the things are that we're monitoring, how well they're doing, how well they're not doing, is represented by this stock here. Next comes the flows. You have inputs and outputs, inflows and outflows. In our case, the inflows would be health data. And the outflows would be your alerts, your notifications. These flows are constantly updating the state, right? So if you were to look at your monitoring system state at any given time, you would see how many things are healthy and how many things are not. And then finally, she describes feedback loops. There are a number of different feedback loops in thinking in systems. The one that we're going to focus on is the balancing feedback loop, and its job is to either maintain or correct system behavior. And this is where I would venture to say that for those of us who have been dissatisfied with our monitoring systems at any point in time in our careers, even if you're maybe still dissatisfied today, this is why your systems, your monitoring systems, are not getting feedback from all of you. And therefore, by definition, when they lack feedback, they are incomplete systems. If you have seen the HBO series Chernobyl, there's a scene where one of the engineers in the room walks over to a dot matrix printer. Remember those? Pulls a print off the printer and reads it aloud. It says, "The computer says that we should shut the reactor down." And he walks it over to the shift supervisor, Anatoly Dyatlov, this character right here on the left, or yeah, your left. And he throws the paper down. He says, "Of course the computer says we should shut down the reactor. It doesn't know we're running a test." The computer was completely out of the loop. The computer was viewed as something entirely separate from the engineers in the room. When we describe our systems, it's very common to draw very high-level diagrams like the one you see here. We have very distinct boundaries around a service, for example, and the thing that's doing the monitoring, making sure the service is up, it's healthy, whatever. And of course, we have our engineers over there somewhere. And this is okay. This is a good start. It's a very mechanistic view, right? There are just these cogs, and that's how things work. But those boundaries are arbitrary, which means they're entirely negotiable. While each of these blocks here is a distinct system, it could be described in terms of a stock, flows, feedback. we could just draw a line around them and call that the system, right? This is our stack, for example, that powers the business. It's a larger whole. We could go a step further and draw that line around everything, the humans and the computers. And what you'd end up with, just because I drew a circle here, is what's referred to as a joint cognitive system. And a joint cognitive system is one that's described, it's described a number of ways, but the simplest is that it is humans and computers acting together to achieve a goal. To give you an example of what that might look like, say you are operating a web storefront for craftspeople to sell their wares, or you're serving financial market data in near real time, or just off the top of my head, you're like a social platform that makes it easy to distribute cat pics and disinformation campaigns ahead of 2020. Achieving goals, right? In their seminal paper, Cognitive Systems Engineering, New Wine and New Bottles, Eric Holnagel and David Woods described the design of what they referred to at the time as a man-machine system, what we would call now a joint cognitive system. In fact, that they coined this term, the joint cognitive system. The design of the joint cognitive system is to aid problem solving and decision making in dynamic environments. And part of that joint cognitive system is that all of you, every human, has a mental model of the system. And I think it was Nora who said that each of your teammates likely has a different mental model of that system. Here's the important bit about a joint cognitive system. The system has an image of the operator. And I think that's really important, so I'm going to say it again. In any joint cognitive system, the system has an image of you. And the reason that's relevant is because our alerts, our notifications, are explicit artifacts that are representing the system's image of each of you. That is, when you receive an alert, the information that's in there, it's assumed that it's enough to get you started. It's assumed that you know what to do. If there's no information in there or lack of information, well, it's just assumed you can fill in the blanks. Therefore, this is my argument, if you're receiving poorly designed alerts, it's a manifestation of a poorly defined system image of you. Especially because those alerts, if they're not doing you any good, that really means that either not reinforcing the mental model you currently have of the system, or they're not helping you to adapt your mental model in order to adjust your response. Holnagel and Woods went on to say that one of the primary goals of cognitive systems engineering is to provide designers with tools to help the system image match the cognitive abilities of the operator, of the engineers, the humans. So at this point, we've briefly touched on an abstract, or a definition of a system in the abstract, and we've touched a little bit on what a joint cognitive system is. Let's turn our focus to attention. All puns are intended. So there are 8 executive functions. We're only going to discuss 4 of them today because I believe these are most pertinent to the subject. But if you do any research into attention or into cognition, you're going to come across executive functions. And executive functions are defined as a set of processes that all have to do with managing oneself or one's resources to achieve a goal, just like joint cognitive systems, humans and computers working together to achieve a goal. Further, these are neurologically based skills involving mental control. So when you think of attention, you probably think of being able to focus, mental control, right? So we'll go through each of these. Shift is described as the ability to move freely from one situation to another. When you receive an alert, what are you already attending to? You certainly aren't waiting for that alert. Right? That's not your job. You're probably writing code. You're probably thinking really deeply about some new architecture redesign. You might even be asleep. This is the worst kind, right? And it's probably another talk in and of itself, but it's almost implied that when you receive an alert, you should shift your attention. We never talk about whether or not it's right to take attention from an engineer. You receive an alert, it's just assumed that you're going to do something about it. That's not true, though. Second is initiation. This is the ability to start a task. What do you need in order to jumpstart your response when you get an alert? What information is useful? Maybe a short description of what happened? That might vary. Maybe about why it matters. We've been talking about service level agreements, service level objectives. Are users impacted? This would be useful information. The lack of information is critical because it can delay your response. If you have no idea where to orient your attention, you're likely not going to respond any sooner. Or worse, it might leave open way too many options, and you could delay your response by wasting time on ineffective actions. Next, we've got working memory. This one's pretty simple. This is what you can hold in mind for a task, right? You can remember 7 digits, you can remember 10 digits. I think someone earlier said in terms of dashboard design, you can really hold 3 or 4 boxes in your visual working memory. If we can find ways to aid working memory, keep things in front of people, what would that look like? And then finally, planning an organization. This is the ability to manage your tasks, the things you're working on now and what you might work on in the future. In other words, what is your approach going to be? Have you figured out what you're going to do when you receive this alert? Who might you need to call if you need help? And what I think is really critical, I don't see a lot of this, is what does success look like? Success doesn't mean I don't get paged again. It means that whatever condition has caused this notification to be sent to me now no longer is present and or something better is happening. This is Ranjit Singh. Side note, I want to be Ranjit's friend. He's a traffic cop in India, and he has a very special skill. He dances, and he directs traffic while he dances. And he says, because of his particular set of skills, traffic violations in his intersection have decreased over the last several years. This man is directing attention. He's directing the attention of drivers, bicyclists, pedestrians, keeping them safe while getting them to their destination and scooting across the street. Because we're talking about directed attention, it's useful for us to lean on this definition from David Woods in his paper, The Alarm Problem and Directed Attention. It's a long one. The Alarm Problem and Directed Attention in Dynamic Fault Management, where he says that a cognitive function, or directed attention is a cognitive function that inherently involves the coordination of multiple agents via external media. Sounds a lot like a joint cognitive system to me. Your monitoring systems are the agents that are trying to coordinate with you via the alerts and the notifications that they're sending you. And they're sending them to you because you asked them to. A few years ago, I wrote and released a tool called Nagios Herald. This is when I was at Etsy. We were still using Nagios. Don't laugh. It was still pretty good at the time. And I built it with the notion that computers should do work for us. That they're a resource there to do work on our behalf. And the project would allow engineers to inject context into an alert, right? You could embed a graph, you could do an Elasticsearch query and find out how many times this alert has fired. Anything that you could think of that might help you triage a problem, Nagios Herald could help you inject that into your alerts. And the notion that the premise that I built the tool on is that computers should do work for us. And the more that I've been learning about cognitive systems engineering, the more I've come to recognize that that premise is very adversarial. There's me, there's a computer. In a joint cognitive system, we start thinking about all those things working in concert. So when we discuss designing alerts, what we're really talking about is enhancing the system's image of the operator, the user's mental abilities, and the way we do that is by aiding these executive functions that we have just described. And when we do that, we end up either reinforcing the mental models that we already have or adapting those mental models. Right? You could be working at an organization for 10 years, get an alert that totally changes your impression of how things work. In fact, if you think anything is static within your stack, your alerts are going to tell you otherwise. There's always something to learn there. So what I've done here to illustrate some of these concepts is I have mocked up 2 pretend alerts. And we're just going to build up as we go along. This first one is some machine. We have a single machine. The CPU is somewhere around 85%. This isn't a whole lot of information for me to go on. And honestly, I mean, if this were my machine, I'd be pretty happy because I bought it to process stuff, and it looks like I'm getting my money's worth, right? This is fantastic. And you might be thinking, Ryan, it's 2019. Containers are a thing. Virtual machines, like this still exists. I know some of you work at organizations where you still have vertically integrated products, right? I'm not here to judge your architecture. These things exist for a reason. I am, however, here to judge the quality of your alerts, and this is poor. Let's say we're to add just a little bit of information, just a correlation between high CPU utilization and increased response latency. That sounds fantastic. I know a little bit more about why this matters. Even more importantly, hey, the current 90th percentile response time is somewhere around 500 milliseconds, and there's an SLA. Maybe it should be an SLI. I don't know. I'll talk to Alex after this. But that indicates to me that this needs attention right away. So this has actually just helped me shift, because even though I'm not quite sure what happened, I know why it matters. There's a customer out there probably who's going to be affected by response times shooting through the roof, or we might have to pay out, right? This also supports my initiation function because 500 is kind of close to 600. So I'd rather giddy up and go. And finally, my working memory is 80 because now that service level is right in front of me. I know exactly what I'm looking at. What if I were to tell you that this host stores customer data and it's depended on by 2 other systems? Well, this aids my initiation function because I might be able to develop new leads, new responses as a result of knowing that. It also helps support my planning and organization function because there are 2 other teams potentially that I might be able to rely on. I might at least have to coordinate with them, right? The response just got bigger. Here we go. This DB data, whatever that is, it's half of a pair of hosts that are storing data. That scares me. But my working memory is now 80 because now I know there were 2 machines, and this is 1/2 of that. And my planning and organization functions are also facilitated because I'm likely to take a much more considered approach to addressing this issue than, say, if this were one machine out of 50, right? How about this? Could it be useful to know that this alert is triggered, looks to be, maybe an average once an hour? You bet. Because what if one of your teammates had identified an hour earlier there was a problem with some runaway cron? Oh, that's right. Someone's already working on this. I don't have to address this issue. So just as important as it is to aid an engineer's ability to shift into gear to do something, it's just as important to let them know you don't have to shift. You don't have to pay attention to this. And now I know, in this hypothetical situation, that, I don't know, Sue has this. Sue's working on this. And when she's done with that, we aren't going to get these alerts anymore. All right, here's our second alert. I really don't know anything about payments processing, so if there are any payments engineers out there, you're probably going to start sweating with this example. But it says 75% of credit card payments are still in the authorization phase. Groovy, right? I like when they're authorized. Sounds useful, right? I don't know what I should do with this. I don't know if I should do anything with this. What if I told you it's been an hour and the average time to process credit card authorizations is about 5 minutes? Okay. Now my shift function has been supported. I know I should do something about this because 5 minutes is not really close to an hour. Although I'm not really sure if this is an issue with our systems, if it's the payment processor, so I'm not really sure where to get started. What if, hey, payment processor, pay friend. Sounds legit, right? They have been experiencing an increased number of errors over the last hour. I've also got this totally believable graph that shows something going up and to the right that can't be good. This aids my initiation because now I have a much clearer idea of where to begin poking around. How about this? A lot of fun, right? I have a toll-free number and an account number. So if I need to maybe engage our account rep at PayFriend, I've got that right there in front of me. I can now plan. I can organize my response around whether or not I should incorporate the payment processor into addressing this issue. Also, this is part of my working memory now. I don't have to go look that up. It's in front of me. And this is probably where most people would sweat, like, listen, Brian, you can't just, there's money involved. No, you don't know. But maybe we do have a process where you could flip. Maybe you have two payment processors. You could flip from one to the other. I don't know. Like I said, I totally made this up. But pay attention code's ready to take our payment authorization processing, right? And this is more aid to the planning and organization executive function, because I have a possible relief valve. And we could go a number of different ways. We could add a whole bunch of different contexts in here if we wanted. For example, I've worked with teams that wanted information context from user forums in the alerts. Right? There's certain channels that they would monitor, and they wanted to know if all of a sudden there was a spike in activity at least. So we would just count messages over the last hour. Maybe they actually want content. But any information that would help you as the engineer know how to organize, know whether you need to shift into attention, know what you need in order to get started, to be able to coordinate with other teams, for example, search, payments, customer service. Customer service folks might be interested in this, for example. These are all ways that we're able to aid cognition, to aid those executive functions. So I want to come back to this diagram of the system in the abstract. Right? You've got your stock in the middle, you have your flows left and right, and you have your feedback loop, your balancing feedback loop, whose role is to maintain or correct a system's behavior. And now when I'm talking about systems, I'm talking about a joint cognitive system, the one where humans and computers are acting in concert to achieve a goal. And Hornagel and Woods continue to say in their work that the virtue of cognitive systems engineering is that the system, again, the joint cognitive system, is thought of as adaptive, and that the goal is to improve the function of this system as a whole. So the only way for us to get better is for the computers to get better, which means we need to get better so the computers can get better. And when they wrote those words, when they wrote these papers, they were looking at largely static dashboards and displays and power generation and maritime and operating rooms. But we have this benefit that we work, I'm assuming, most of us here are working in software. And software is nearly immediately and infinitely malleable. And so we can use that to our advantage to inject feedback into our system. And that feedback should always be about helping the system's image match the cognitive abilities of the operator. And I'm convinced that if we do that, then we will start to see greater satisfaction in our monitoring solutions. We will strengthen the joint cognitive system that we operate within, and we will start to achieve our goals. And I had to add this in. This happened this morning. I should have caveated that I'm not a professional designer, but I do appreciate the challenge of design. This is how our toaster operates through the eyes of a child. This is my son. He was making a bagel. And we've only ever had a double toaster. Does anyone see what's wrong here? Anybody see it? How many of you would have put both halves of the bagel in the pair on the left or the pair on the right? You're all obviously wrong, because you put one half in the pair of slots and the other half in the other pair of slots, and you run them both at the same time. What this represented for me is a non-computer example of a design where the system, in this case the toaster and the little boy, the image of the toaster's, the image that the toaster had of that person operating this toaster was that they knew how to use a toaster. Right? If there had been maybe some arrows or something that says, insert bagel here, not bagels, right? Maybe that would help. But I don't know, I thought this was relevant. Anyhow, design is challenging. And finally, just to wrap up here, I've got a number of resources and references, including a long form blog post of this presentation. If folks want to go read it, references to the papers that I mentioned here, and a number of other things. And with that, I'm done. Thanks, folks. Yeah. Yes, please do so. The question was, any thoughts on keeping these up to date? So if I understand the question, in the example where maybe someone had decided to switch payment processors, if there's different context that comes as a result of using that second payment processor, you mean like a different context within the body of the next alert that might come in? Okay. Ask the question again. Oh, best practices. That's always a tricky one. It's the short answer is it depends, and the longer answer is it really depends on what is important to you and your organization. Best practices, you start implementing that feedback loop at a minimum, right? If you are, say you have a weekly or whatever the period is, you've got a team that's on call, and you've got a handoff ceremony, whatever, or even if you're generating a report, someone's writing something up, whatever it is, that should be part of that review process. What works in this thing? What did we find isn't working? Why are these things not working? Why can't I make sense of this thing? This thing's no longer useful. We should get rid of it. In fact, can I tell a quick story to answer? Right? I've got time, right? No one told me the shiny shins were coming. I'm going to exit stage left. Very, very brief story. There was when I was at Etsy, we had this alert that went off one week. So the gray, we're going to have another hill to die on here, a gray GIF alert. And we're going through this on-call handoff report ceremony that we had, and the engineer says, "Yeah, I don't know what this was. I just bumped the threshold and went back to sleep." Second week comes around, gray GIF alert fired, and I did the same thing. I just bumped the threshold, the engineer said, and went about my business. Third week it comes around, lands again, right? And none of us knew what this was. We'd asked around. We had no clarity on what it was. We had no context on it. And we made a decision, delete it. We got rid of it. There was nothing actionable about it. It turned out, we found out what it was later, and we certainly didn't need it. But I don't know if this really answers your question, but like that hopefully illustrates that there was a feedback loop process there. We're constantly reviewing these things and understanding if they were useful to us. If they were, we kept them, we modified them. If not, we got rid of them. Any other questions? All right, thanks, folks.